Yes, I am Svein Arne from the National Library of Norway, and I'll try to walk you through activities at the National Library of Norway. So this will be very practical, and it should be possible to understand at least parts of what we call artificial intelligence. What we try to do in our work is to move from our tradition, our cataloging rules, to something approximate, something good enough. So the good enough is going to be mentioned quite a few times during my talk. So the background now is our library, which is a library, a national library. And the National Library is supposed to be a major memory institution in Norway. So we are supposed to keep more or less everything which is publicly available, like books, newspapers, and also, for example, radio, television, what you find on the internet, and everything else. So we have this Act on Legal Deposit giving us both the obligation and the possibility to collect all this information. We have approximately 500 employees at the moment being, but in fact, we are going to employ 75 more during this year up in Mo I Rana, where one of the departments are. And I live far up north at the Arctic Circle. So going here is approximately 9 hours of travel. The second site is, of course, in Oslo. Today, I'm going to talk you slightly through the motivation for what we are doing, and I'm going to give you a short introduction to one of the major parts of AI, namely machine learning. Machine learning is the area where we have most of our activity. Then I'll go through a series of examples from our laboratory to show you examples of what we can do with machine learning in libraries. And I'll go slightly into what libraries can do for AI as well, and maybe some conclusions and announcements at the end. So why do we work on AI now, and exactly now? Well, first of all, we don't believe that the future is coming. We believe that we create future. And we believe that AI is going to be a major part of the future, which, of course, means that we have to work on AI to create future. And it is possible right now. It is possible because we have hardware, we have the software, and we have the digital content. So these are the three major feet that AI stands on. And we are libraries. We are libraries, and if we don't use AI, who should? Because we have in our digital libraries large amounts of data which we form as information. But the users are seeking knowledge, of course. And one of the purposes of libraries is, of course, to provide knowledge, access to knowledge, to support maybe wisdom. This is the traditional hierarchy, as you know it. And AI is a major part, maybe a major part of this. And right now, we have low-hanging fruits in terms of AI. We have the software. We have open test environments like test sets and learning sets, ImageNet and others. And we have a lot of commercial services based on AI, based on machine learning. I go more practically into those. But I think the most important part right now is the software. We have chosen to use TensorFlow from Google, which I call a democratized software. Democratized in the sense of being available, it's free, and it's possible to use without very skilled skills. So more or less every technician is able to use it. A little while ago, we started off with an activity at the National Library of Norway to study our metadata in principle and practice. We wanted to change our work on metadata. After a short while, we, by accident more or less, discovered that machine learning was really available as a technology. We could use it in terms of producing metadata, doing quality control, and other parts. And after some small experiments, we decided that this is so important that we have to have a laboratory. We called it Nancy after Nancy Pearl. Some of you might know the Nancy Pearl action figure to the left, the plastic thing, American, which can do like this. There is a knob on the back, and she can shh. It's more or less for fun. It doesn't mean anything. But we had Nancy opening our conference in Oslo in December, and she loved being giving the name to our activity. So our AI lab is a defined activity reporting directly to the director of the library. Excuse me. And it's supposed to give inputs to a conversation about AI. So we should be able to do wise choices through practice. We are currently 3 to 4 people, and we buy some services. At our library, this is possible because we started off with a strategy process back in 2005. And we tried to figure out if there was anything that had happened with significance to the library. And we found one thing. It's called the internet. The consequence of the internet is, as we know, that the users, they expect to find everything there. If it isn't on the internet, it's not there. It doesn't exist. So we simply decided to digitize our collection. Not parts of it, but the collection. And make it available on the internet. Today, a few years after, we started off in 2006. More or less all the books at the National Library, which is more or less all the books published in Norway, are digitized. Half of all the newspapers ever published in Norway are digitized. We have a large radio collection, we have television, we have moving images, and photographs, you name it, we have it. And we have heavy use of the digital collection within the library. So it is a very good platform to stand on for machine learning. Now, I mentioned machine learning quite a few times already. So let us have a quick view into some of the principles for supervised learning. So there are 3 main directions of machine learning. The unsupervised, so the technology is more or less learning by itself. We have the supervised, where we try to teach the technology, and we have reinforced learning, where we try to reinforce existing achievements by the technology. It is important that you understand that moving into the era of AI, moving into the era of machine learning, is a major change in terms of moving from what we know as precise, predictable, if then else, to something approximate, something based on learning, something good enough. We have to learn to work in other ways in terms of using technology. And I'll just walk you through the principles of supervised learning. So this black box, which is blue in this case, TensorFlow, is the software we use. And honestly, we don't have a clue on what is going on inside. We know there is heavy mathematics, statistics, but we don't understand it. And it is extremely complicated. There is a debate on whether we should understand it or not, but we have chosen not to use much resources on understanding. Then we choose some of our collection to train this technology. For example, content with metadata. And we hold back some of this collection to do testing. And when, in this case, the blue black box, Nancy, is good enough, we can move it into some production or use. Very important in this case is that we have to have a clear understanding of how we measure the performance of Nancy or the technology. So we can go back and do a new training, or maybe choosing some other parts of technology to make it better. Or we can choose to go on and put things into production. So let us say, I want to produce new catalog data without human intervention. To do this, I would pick lots of books with the belonging catalog data. I would have some unread books, for Nancy in this case, and I will test what she's producing of catalog data and compare it with my measures, my facet. And good enough, she will get new books and do the classification. So this is more or less the principle on which we do more or less everything. So let me walk you through a few examples from our laboratory. The first little experiment we did, and these examples are small-scale experiments, which we, a few years ago, 2-3 years ago, wouldn't be able to do. In this case, we did an experiment taking perhaps 1 week, 5 days of work. What we did was to take groups of literature where somebody else, I don't know who, did some kind of classification of our literature. They put our literature in 4 major groups, and I haven't seen any description of the groups. I have only the names of them. So one book is belonging only to one group. We let our Nancy read a few thousand books in each group, and then we started to test. And after a week, she was able to classify new books with the right answer in 95% of the cases. So she didn't know the rules, the description of the groups. She learned just by reading. The second example is Dewey, as I presume you know. So we split, we try to place our knowledge in 10 major groups. We split those in 10 more groups, each of them, and so on. So the challenge now is to try to classify scientific information in 3, 4, 5, and 6 digits. Dewey. We use our database for scientific information as a learning platform with born digital documents. Where we don't have enough documents, we make some artificial documents based on just exchanging a few words in each article. Kind of cheating, but it works. After a short while, we perform with a 92% performance. So in 92% of the cases, Nancy is right. and in some rare cases, 100%. What is interesting is, of course, also to look at in this case, the 8%. And if you get closer into it, you might argue that the librarian might not be right, but Nancy might. I said might. And this illustrates the relationship between the number of documents in each Dewey number and the learning curve, and the precision in Nancy. So I joined one of the parallel sessions today on AI, and there was much talk about a system communicating with the user by natural language. So how do we teach systems to talk? Well, English is kind of trivial because the English language is so huge. Norwegian could be used as a way of encrypting information to most of the universe, because it is a small language. So we would like to make a larger corpus of training data for learning natural language based on machine learning. So we use machine learning to do speech-to-text, but it's not really precise. It's not really good enough. Then we try to establish some kind of a machine learning-based system to do quality control by reading perfect text. Then we can pick out pieces of the first output, which probably is good. And doing this on a large collection, we can make a large corpus, which we can give out to companies who produce those systems to speak to our patrons. So we always try to be more effective. In our library, we do a lot of cataloging. In this case, we have the Sami bibliography, which is keeping track of literature information relevant for the Sami population living far up in Norway. And for some reason, we have a hole in this bibliography from 1988 to 1992. So we would like to find candidates based on our digitized collection. And we let Nancy read information which belongs today to this bibliography. And we have a small system where the user librarian can have a quick look at the candidates, go into our digital collection, and find out if the candidate is relevant. And in most cases, it is. Let us have a quick look into commercial services. So what you have seen now is our work on training systems ourselves. But there are some vendors like Google, Amazon, Clarify, who has services which are based on machine learning. And they can do amazing things for you. They are easy to use. And they typically do speech-to-text, video analysis, still image analysis, natural language processing, and more. They are very general, so many librarians claim that they are not possible to use because libraries are so special. I think you could discuss that at least. So let me show you first one example. We often use this kind of examples. This is our director, and building examples based on our bosses is kind of charming and gives us room to proceed. But anyway, this is Google doing some kind of an analysis of the image of Aslak. And you can see that there is, it's likely that there is hair, and there is a person, it's probably a man, and so on. This is relatively good, I would say. In this case, Aslak had sort of a Mona Lisa smile, so it's not easy for Google to find out what mood he is in. But it is easy for Google to find out who he is, and also point at places, organizations, and more, even roles. He is a far left-wing politician, etc. So this is rather impressive. But there is more. You have seen this man before, right? You could, of course, discuss this elder and senior citizen. We have some discussions with Google now. But it's much easier to read, right? This could, by the way, be after the dinner yesterday, which was very fun. But this is the best. What do you call it? The proof of the pudding. No, well, this illustrates the notion of good enough. So it is not always good enough. A more relevant illustration is the analysis of a historical image, in this case from Oslo. And Google also provides OCR automatically, trying to find text within images and more. And these kinds of services are very, very easy to make use of. So let me introduce you to a more complex example. We had this conference, the first conference on AI in libraries in Oslo, a collaboration with Stanford Libraries at Stanford University in December last year. And we decided to make sort of an illustration of the possibilities of the technology for this conference. And we spent 8 man-months of work on this example, which is not very, very much when you see the result. So the challenge is to make newspapers, radio programs, and television programs available to the patron. It should be searchable based on persons, organizations, places, and we should have the relationship between those. Most of it should be placed geographically, and we also would like to have some kind of classification, subject classification if possible, and it should be placed in time as well. So what we did then was that we took our digitized newspapers. So all of this is from January 2011. All the newspapers in Norway, 2 radio channels, and 1 television channel for a month. So we took the text out of the newspapers. Red means that we had the software, the functionality already. It's traditional, nothing special. For television and for radio, we did speech-to-text based on Google's speech-to-text services and their video analysis to find objects, to find scenes, etc. Within the television programs. We then extracted the entities like the persons, organizations, and locations, places. And we did a lookup in databases on the net to find the coordinates for places. And since we had the relationship between, for example, persons and places, or organizations and places, we could also place organizations and persons on a map. Then we made a simple user interface to this, working against a search engine. And this is solely a geographical search. So the search is defined by the frame of defining the map. If we zoom into this, more information will show up. And remember, in this case, there is no human intervention. There is no cataloging. Nobody has done anything with the metadata, only our Nancy. On the top here, you will have the information's, the distribution of information along time axis. We have the red ones, which are people, and we have the locations, and below you will have the organizations. If I do a text search, in this case, I did a search for Jens Stoltenberg, our Prime Minister at the time. And I have changed from a map view to a newspaper view because I'm after newspapers. So I did a search, Jens Stoltenberg, and there are some relations to the name Jens Stoltenberg, for example, Norway, or the Labour Party, or the name Maria Amelie. We will follow Maria Amelie. There was a debate on illegal immigration, and Maria Amelie was very much in newspapers as one of the examples of successful illegal immigration. So the length of this bar indicates that there is a strong relationship between Maria Amelie and Jens Stoltenberg. And the newspaper pages here should underpin that. So I choose this newspaper page. And somewhere in this newspaper page, there should be text building up under the assumption of this relation. So look at this. This is done fully automatically. We think it is pretty good. Well, if you go into it, you will find lots of examples of not good enough. But again, this was done quickly to do a demo. And I'm sure we could make a production version of this quite quickly. So the last example then is every morning we sit there and we have a cup of coffee, of course, and we wonder a little about what we don't know, what we don't understand. And we found out that there is a piece of software that we almost understood. So we chose to tear it apart and have a look inside. And then this idea of making, let's say, vector representation of information. A vector is, in this room, you could represent every point in this room based on 3 dimensions, right? So you could define every point in this room by 3 dimensions. When we do work on images, we typically work on 2,000 dimensions. So the idea was to calculate the distance between those such vectors, assuming that if we find mathematical representations of an object which are in such a large space close, they would look similar. There is not very much reasons to believe so, but we decided to follow it. So there is no learning in this case, except we try to understand what is really going on in terms of mathematics. So we did this on, in this example, 150,000 images from a historical database that we have. I choose this image as an example. And again, I've just calculated the distance between mathematical representations of images. And this representation is not possible to use for describing the image. There's no notion of colors, nothing. So this is the result from Nancy. These are images that seems to be close, for some reason, to the one I picked. In this example, I choose the girl with the horse. This is not a horse. But it is good enough, right? Even if there is a cow. So, of course, we had to investigate if this is possible on text as well. So on text, we have at least 2,000 dimensions, and we might have up to 20,000. And we try to again, produce vectors. And we try to compute the distance between those. And now we have no classifications. We have no description of the literature, no grouping, nothing. Only the content itself. So we have a large digital collection, so we picked approximately 300,000 books and did some computation. And this is, now we have to look at me as a black box, which you have to trust. Let's take this. So I have chosen a book by Fridtjof Nansen, his book about crossing Greenland for the first time. And all the books are about journeys, about adventures in the wild. Some by Fridtjof Nansen, some by other authors. And this is the last example, and you can see that, well, this is the main title, and you can see the titles, just by the titles, even if encrypted for you. You can see there is some similarity. Right. So that was the examples from our laboratory. We do a lot of things, again, small scale, as a platform for conversation. But some ask, what can libraries do for AI? And I think libraries may play a very important role in the development of AI. because we have the digital content and we have the metadata. So we can give others access to these collections to build their functionality, to train their machine learning-based systems. And if we cannot give them out, we can give access by building laboratories inside our organizations. Our domain expertise is also a valuable resource. We can go into collaboration with the industry and provide our expertise. And we can make pre-trained models and give them out. So I have this classification module for books, and everybody can use it. So the distribution of pre-trained models is trivial. So I'm getting close to the end. So far, we understand that we don't really understand. We have been working on this for quite a while now. We have done a lot of experiments, but we understand that we must understand. And we also understand that there may be something that we should be looking for, which is not so visible. I think that the easiest way to go forward is to copy ourselves, what we have done always. So most of the examples you have seen, they are just imitating ourselves. So what could we do if we stopped limiting ourselves? Our internal workflows may change quite a bit. They may be more effective and they may be better. Our view on metadata may change radically. What kind of metadata do we need when we have systems where the metadata is kind of in the functionality? We think that our collections will be better accessible, not only because you can search better, but because we will be able to represent the knowledge within our collection and present the knowledge for the patron. So there will be something more than the data and the information. We will be better at knowledge. Altogether, this means that we will be better libraries. This will support us in becoming the future libraries, whatever that is. I think that is a major question. What is the future library? What is the role of the libraries in the future in light of AI? So there is also a need for collaboration. Stanford Libraries and National Library of Norway has decided to initiate an international community on AI for libraries, archives, and museums. So we will, as part of that, also have a new conference on AI in libraries, this time in December in Palo Alto at Stanford Libraries. It will be the next version of the one we had, and you're very welcome to join us there. There will also be a workshop the day after, and on the last day we will gather some people to initiate this community on AI in libraries, archives, and museums. So that's about it. We have some time for questions.
I might just take issue with your matched image not being good enough. But, you know, I might be on my own there. Any questions or comments for Svein Arne on the floor?
Hi, thank you very much for your presentation. It was really, really interesting. I'm Libby Homer from Anglia Ruskin University, and I was just wondering what your thoughts are on sort of systems suppliers and library management systems and where they should be at with this. Some of the things that you sort of said is the kind of things that I've been attempting to urge our systems supplier to do, but they're not particularly receptive to that. So I just wondered whether you'd been talking to them or whether the lab was entirely separate and where you think the kind of usefulness of working together might be on that.
One of the things that have surprised me as well, I've been working with technology all my life, and I've been working with digital libraries for quite a few years. What is really surprising me is that the people I've been working with, and also commercial companies, are the most conservative in terms of taking this technology into existing systems and moving forward. I'm afraid that for a while we will not see very much of this kind of technology in our existing solutions. Sorry to say that, but that's my feeling. And it might be the case that, again, in our case, we use Ex Libris, we use Alma from Ex Libris, which is, as far as I can see, just a digital copy of the wooden cases that we had. And it's not very impressive. I think this kind of technology will make a huge change to that. It will challenge everything. My feeling is that we haven't even seen the beginning. It will be so strong.
Thanks, really interesting talk. Neil Gridley from GIST. So I get the point about libraries and librarians needing to adopt a good enough approach. And I think there's a lot of mileage in that. But if we're getting classification right, say 9 times out of 10, and we can, as a community, learn to relax about that, if users aren't finding things 1 time out of every 10, and that time that they're not finding it is extremely important to them, do they also have to relax about not finding stuff?
Sorry, I didn't hear the last.
I guess what I'm asking is there a process of education around users and the process of discovery where the users might have to also relax about not being able to find that thing that they're after 1 time in every 10? Do you understand?
Well, I think the situation today is more or less exactly the same. What we assume is precise and complete is not. So librarians are different. They are different in their practice. And the quality of the work is not necessarily the best all the times. So there is a variation. And, but we believe it is perfect. We believe it is rather on the edge. But it is not. So for the user, I think moving to this kind of technology where we accept good enough, but we have to know, again, what good enough is. And we should be able to tell that. I don't think the user will recognize it. They will not see it. They will not see any difference. They might even find more and better. I believe they will.
Hi. There's been a lot of debate in the UK about some of the ethical questions that come up around AI, and you and I both saw the racist soda dispenser presentation also, which is very powerful. What questions should librarians be asking when they buy commercial AI services to ensure that we are behaving in an ethical way and being true to our values?
That's a hard one. I don't really know. And my gut feeling is that we have come so short yet, so we don't really know. I think it is. I think we should do, like we do, a lot of experiments to really get experience, making us able to do good choices and learn through experiments. There is a large debate on bias in AI systems because, as you have seen in my presentation of machine learning, what you get out is more or less what you put into the system. So if you, for example, use images of mostly white, wealthy people, the classification, the performance of the system might be pretty bad on other parts of our population. If you go just a few years back and have a look at our literature, we might not like all we read based on today's daylight. So the bias era is also difficult, challenging. And if we are supposed to buy systems doing classification, we have to do at least some measurement of the performance. You cannot ask the vendor if it is good enough. You have to find out.
Have any more questions for Svein Arne?
I'll be around for a few hours, so please get in touch.
All right, thank you so much. I think you gave us some